Here is an explanation for the answer to final exam question number 39 in Electronics Demystified, 2nd edition. If you have the printed book, please refer to page 425. If we want to build an effective SSB, that's single sideband wireless transmitter, which of the following things must we do? Then we're given 5 choices. Maximize the bandwidth, suppress the carrier, differentiate between mark and space, amplify both sidebands equally, or ensure a linear relation between frequency and phase. Well, B, suppress the carrier, is the correct answer, and we can see that if we go back to chapter 9 and look at the diagram, figure 9-8, of a suppressed carrier lower sideband signal. Lower sideband. Notice the carrier frequency represented by that dashed line, frequency relative to carrier in kilohertz, +2, +4. The bandwidth of the signal, as you can see, is roughly 3 kilohertz. That's typical of a single sideband signal. This particular signal shows the lower sideband. When we take a single sideband signal like this and look at it on a spectrum analyzer, as we would see here, the information, the voice information, is contained in one of the sidebands, either the lower sideband, which is shown in this case, or the upper sideband, in which case we would see this very same information here, right here, mirrored on the other side of the suppressed carrier. But the important thing here is that in a single sideband signal, the carrier itself, which existed in the original amplitude modulated signal, is suppressed, and that is done typically by a circuit called a balanced modulator. A balanced modulator takes an AM input and provides a double sideband suppressed carrier output, and then we can get rid of one sideband or the other using a highly selective filter. But the correct choice for this question is B. We must suppress the carrier if we want to build an effective single sideband transmitter.